Well, hello and welcome back to math class. We're going to start a new unit about algebraic expressions today. So everything we're going to do with algebraic expressions is going to be about making equivalent expressions. It's got that root word equa in it, meaning equal. And so an equivalent expression means they equal each other. They just might be written in a different way. For example, we can say 6 of something like 6 eggs is the same as a half dozen eggs. They're equal to each other, but we can say 6 of one, half dozen of another. All right, go ahead and pause and copy this down. Make sure to create a new entry in your table of contents. All right, so in the next couple of lessons, actually, because we're going to bunch it all together about algebraic expressions, we're going to look at what they are and how we can add, subtract, factor, and multiply these things. And ultimately, we're trying to make equivalent expressions. And that means they have the same value even though they might look different. Okay, so we got a lot of vocabulary since we're starting a new unit. Whenever we have an expression like this, I know it's an expression because there's no equal sign. And all these things separated by plus or minus signs are terms. So these are terms. Negative 2x, 16, and x, those are all terms. Go ahead and copy that in. All right, if we have a number before a coefficient, a number before a variable, the letter, we call that the coefficient. Just like when in chemistry, we're talking about 2H2O, meant there was 2 H2O molecules total, and we called that the coefficient. Same here. So this negative 2 in front of the x would be the coefficient. Whenever you have x by itself, you can imagine a 1 in front of it. The thing without a variable in it, the ones basically, is called a constant. And today we're going to focus on combining terms that are alike. And when we say like terms, that means they have the same variables to the same powers, or we can even group constants together, the ones together. Those are also considered like terms. So go ahead and copy that in. And again, like terms have the same variables and powers. So these are both x's, so they're like terms. These are both ones, they're like terms. Okay, let's just do a little check in here. So what are the terms in this expression? The terms are 6n, negative 7n, negative 4, and n. What coefficients do I have? Do I have things stuck to letters? Yes, I do. I have that and that. Are the easy ones to see. So I have 6. I'm going to grab the sign with that. I have negative 7. And then I have a hidden secret 1 right there. What are my like terms? What could I group together? Well, I have a lot of n's here, so I could call these my like terms here. So I have 6n, negative 7n, 1n, and they could be grouped together. My constants are my ones right there. I have a negative 4. And what variable do I have? My variables are my letters. So in this expression, there's only one variable, and it's n. Okay, so we're going to learn we're going to learn today about combining like terms, and it's going to help us later on when we do really complicated equations. It's going to help make them easier to solve. So I'm going to start it off with playing a little bit of a funny video here. Oops, it's not going to work.
Hi, welcome to Burger Nation. How may I help you today?
Let me get 2 hamburgers with just pickles, 2 cheeseburgers with another cheeseburger, everything on them, 4 more hamburgers with everything, a cheeseburger with no pickles, and a cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one, everything but pickles, mustard, and tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and a large Sprite, 2 large Cokes and a small Sprite, 5 large Cokes and 1 large Coke and a small Coke, 3 small Cokes and a small Coke and a small Coke.
Okay, will that be everything?
Yes.
Gotcha. That's 2 hamburgers with just pickles, 2 cheeseburgers with another cheeseburger, everything on it, 4 more hamburgers with everything, a cheeseburger with no pickles and a cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one and everything but pickles, mustard, and tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and a large Sprite, 2 large Cokes and a small Sprite, 5 large Cokes and a small Coke, 3 small Cokes and a small Coke and a small Coke. Is that correct?
Not quite.
All right, despite being funny, how could they have made that order way more easier to understand? They could have put the total number of Cokes or fries or burgers together instead of listing them off, although it's pretty impressive that they could memorize all that. So combining terms in math it works the same way. So we're putting the Cokes with the Cokes, the burgers with the burgers, the fries with the fries. So we're taking something long and complicated like this, and we're going to just take all our X's and put them together. And we're going to just take all our ones, our constants, and put them together. Okay. Another way of visualizing it is with algebra tiles. So if I had 3x plus 4x, I could model that by going 3x plus 1x. And when I combine them together, how many x's do I have? I have 4x. Okay, what about 3x plus 3 plus 2x? So I'd model that by doing 3x's plus 3 ones, my constants, plus 2x's. So what could I combine here? Well, I'm going to put my burgers with my burgers, put my x's with my x's, and now I can see that I have a grand total of 5x plus 3. All right, one more complicated one, 2x plus 4x minus 5. So I have 2x plus 4 plus 4x's and minus 5, which I'm going to model by thinking of it as plus negative 5. Okay, well, I can put my x's together. That's easy enough to do, and I can see that I have a grand total of 6 x's. When I put my ones together, you might remember that when you get a positive and a negative together, when we did counters back in the day, they cancel out. They make 0 pairs. And so I have positive 4 and negative 5. This business zeroes out, and I get negative 1 here. So I get a grand total of 6x minus 1, or I could say 6x plus negative 1, same deal. All right, so go ahead and pause and copy down these steps. So the way we're going to do it on paper is we're going to box our variables and circle the constants. We're going to make sure to grab the signs like we did back when we were dealing with integers. Then we're going to put our variables together that are the same variables, and then we're going to put our constants together. Okay, so step 1, box the variables, and I'm going to circle the constants. Notice how I grabbed the signs. And I'm going to draw little V's coming down like this to show how they go together. And so I'm going to put my x's together. 3x plus 4x is 7x. And I have negative 3 and positive 11. Positive plus negative, or negative plus positive, subtract. And positive wins. So I would get that is a grand total. Here's another example. I'm going to box my variables, the ones with letters. I'm going to grab my signs on here, and I'm going to circle my constants. You can use 2 different colors if you want to. Like you can use a color for your boxes and a color for your variables. All right, so when I go to combine these, I have positive 6, negative 7n, and then what do I have hiding in front of this n? I have a positive 1. So if I put these 2 together, I have positive 7n, and I have negative 7n, and when I put those together, I get 0 n's. And then I get a negative 4, and I don't really need to put 0n at all, so my final answer would actually be negative 4. Okay, let's get some in our notes, shall we? And again, if you want to use 2 different colors, it's a really good idea. All right, I'm going to very neatly box and circle. Don't mess up your original here. You want to be able to read your example. And I'm going to put any of my variables together. I'm going to remember there's a secret 1 hiding in front of that, and so that's going to give me a grand total of 6n, and then there's nothing to combine that with, so I'm just going to have 6n plus 3 for that first one. Go ahead and copy down this example, and again, I am going to very neatly, or if you need to, go ahead and write it twice, box my variables. I'm going to circle my constants, and this just helps me see my signs, helps me see what is the same. So I can take these 2, because they're both x's, and put them together. That gives me 14x. And then this guy right here can just come down and be all by itself, positive 4. And I'm going to just draw a line there to show that. All right, let's do a trickier one, shall we? Okay, whenever I have a negative outside parentheses like that, that means everything inside is negative. All right, so note that. And let's make everything inside negative. We're going to do the opposite, basically. So what's the opposite of negative, or sorry, what's the opposite of 3r? It's going to be negative 3r. What's the opposite of negative 12? Minus minus turns into a plus. So I'm going to rewrite that part like that, and I'm going to bring this business down. Okay, and now I'm going to go back to my boxing my variables, circling my constants. 2 colors is also cool. And then I'm going to combine here. So when I put my two chunks of r's together, I'm going to get negative plus negative, you add same sign, so I get negative 6r. And then when I put my ones, my constants together, I have positive plus positive, you add same sign, and I'm going to get positive 19. All right, last one for the notes, and then we'll call it quits for this video. All right, so I'm going to be on the lookout for any negatives on the outside of parentheses, which I don't have. So now I can just go about my business of boxing my variables. Grab those signs. I'm going to circle my constants and just grab the sign closest. And then I can combine away. Positive 4 and negative 4 actually cancels out, and so I have 0 y's there. And then I'm going to put my 4 and my negative 3 together, different signs subtract, and I have a positive 1. But that looks funky. I'm never going to write 0 y's, so my final answer would just be 1. All right, so that's it. I hope that wasn't too confusing for you. Be sure to come in tomorrow with any questions that you have. Look over those examples, make sure they make sense, and we're going to jump in and start practicing right away. So get a good night's sleep, and I'll see you in class tomorrow. Bye-bye.